Good day, everybody. Welcome to my course on pipeline wall thickness calculations. As you can see in this image that two pipelines are shown which are supported over various supports. Both of these are above ground pipelines, and as these pipelines carries certain fluids, it may be gas or liquid, at certain design pressure, and sometimes again pipelines can be subjected to external pressure also. So because of those external, internal and internal pressure, the pipe wall thickness has to be sufficient so that there is no mishap or bursting or any failure happens, and thickness is sufficient to carry those fluids under pressure. And because of this reason we have to perform pipeline wall thickness calculations based on code given guidelines or formulas, and we have to assure that the thickness is sufficient or the pipeline strength is sufficient with that thickness to maintain the system integrity. This is the reason we have to perform pipeline wall thickness calculation. So in this course you will be able to learn the following points. First is need for pipeline thickness calculation. Means what is the reason that pipeline thickness calculation must be performed during initial phase of any engineering project. Specifically, rather I can say that pipeline engineering project where pipeline is involved. It may be a gaseous system or liquid system or two-phase flow system. In all cases, we have to perform the pipeline thickness calculation. Then in the next module, we will be learning steps for pipeline thickness calculation. Means what are the steps or methods that we have to follow for calculating pipeline thicknesses based on different codes, guidelines or specifications. Then in third module, we will be learning a sample case study of pipeline thickness calculation for unrestrained pipeline. Unrestrained pipeline means basically the above ground pipelines which is not restrained to move or restrain axially. So above ground pipes are usually known as unrestrained pipes. So first case study will be the pipe thickness calculation for unrestrained pipeline. Then next module will be sample case study of pipeline thickness calculation for restrained pipeline. Restrained pipelines are buried pipelines or underground pipelines. So the considerations we will be checking that how we proceed for pipeline thickness calculation for a buried or underground or restrained pipeline, and you will be seeing that there is a lot of difference in pipeline thickness calculation for restrained and unrestrained pipelines. Towards the end, we will be learning or we will be knowing some of the additional checks that are required for pipeline thickness calculation. So name or methods of those calculations which will be required after the pressure design thickness is des- designed or calculated, and then the actual pipeline thickness is selected, and after that also certain additional checks need to be performed for pipeline thickness calculation. Now what is a pipeline? A pipeline is a network of transportation system used to move goods and materials. So pipeline systems or rather pipelines carry a fluid from one location to another location. It is a transportation system. And what are the products it usually transport? Pipelines transport a variety of products such as oil, gas, sewage, slurries, and water. However, the most common products transported are for energy purposes, which include natural gas, biofuels, liquid petroleum, and recently what we all are talking about, that is hydrogen. So all these products are transferred through the pipelines from one location to another location. Now, need for pipeline thickness calculation. What is the reason that pipeline thickness calculation is required? Pipelines provide the most efficient means of transporting fluid from one point to another, as I already mentioned, and most importantly, they transport or transfer liquid hydrocarbons. Pipelines can be made of metallic or non-metallic materials. So they are they may be made of steel, means carbon steel, DSS, duplex stainless steel, etc. And at the same time, they can be made of non-metallic materials like GRP, FRP, HDP, etc. Based on the application requirement and temperature and pressure capability, this type of materials are decided. However, in this specific calculation, we will be talking about metallic pipeline thickness calculation, and the case study which I will be giving or I will be taking a carbon steel material with API 5L grade X42. Liquid hydrocarbons are mostly transported using steel pipelines. Steel pipelines that transport liquid hydrocarbons must have sufficient strength to withstand the internal and external pressure imposed on the pipeline. So whatever internal and external pressure is imposed on the pipeline thickness should be strong enough to carry or to restrain against those pressures. Other external and internal loads shall also be considered in the design of the liquid hydrocarbon pipeline. The pipeline's ability to resist the load is considered as a function of the strength, which is also related to the thickness of the pipeline. So in one of the term, we sometimes say that thickness decides the strength of the pipeline. So more thickness means it will be having the more pressure as well as load withstanding capabilities. Now this course will focus on calculating pipeline wall thickness and selecting appropriate thickness with a focus on pipelines made of carbon steel material API 5L X42. In addition to performing the wall thickness calculations, inputs to the wall thickness calculation formulas also will be explained. Now, there are various regulations, codes, and standards that govern the pipeline thickness calculation methodology. The method and procedure to determine the pipeline material thickness might differ depending on the applicable regulations, codes, or standards utilized. It should be noted that the ultimate governing regulations are the local regulations and standards. Other codes can be utilized provided the local regulatory requirements are met. Now, some of the most prominent codes and standards that are utilized for pipeline system design are ASME B31.4, which is the international standard for pipeline transported system for liquids and slurries. Then ASME B31.8, which is gas transmission and distribution piping system. Then there are other standards like ISO 13623, petroleum and natural gas industries pipeline transportation systems, PD 8010 Code of Practice for Pipelines Part 1 Steel Pipelines on Land. PD 8010 Code of Practice for Pipelines Part 2, which is used for subsea pipelines. Then CSA Z662, this is a Canadian standard which is used for oil and gas pipeline systems. Now, amongst the standards and codes that I mentioned just now, ASME B31.4 and ASME B31.8 are the very prominent and widely used worldwide. So because of that, in our example and case studies, we will be using these two standards, that is ASME B31.4, which governs the pipeline transportation systems for liquid and slurries, and ASME B31.8, which governs or which provides the guidelines for gas transmission and distribution piping system. Now, calculation of the minimum wall thickness of a given pipeline diameter and selection of actual thickness is one of the most important basic design considerations for any pipeline project. So whenever any pipeline project is awarded and you know the pipe diameter based on process requirements like flow rate, pressure drop, etc. So once diameter is finalized, next step is you have to decide the pipeline thickness. And that is one of the most important basic design for any pipeline detailed design project. This is one of the basic activities that is performed at the initial stages of any pipeline detailed design project. Now, who is this course for? Means who should attend this course? Obviously, from the topic subject itself or topic title itself, you are aware that this is basically a topic for pipeline engineers. So all the fresh and experienced pipeline design engineers who wants to learn how to calculate pipeline thickness or actually learn the methodology for performing pipeline thickness calculation must attend this course. Then all pipeline designers who know that this is the thickness need to be considered, but from where that value of that thickness came, if he wants to learn those methods, he should take or undertake this course. Then pipeline stress engineers, then piping engineers who wish to switch to pipeline engineering, because many a times we see that piping engineers shifts their department or changes their stream from piping to pipeline, so they should learn how to calculate pipeline thickness, because they may be aware of pipe thickness calculation, but pipeline thickness calculation comes with many additional considerations, so they should also learn these steps. And finally, anyone who wishes to understand how pipeline thickness is calculated and what are the steps involved in pipeline thickness calculation can undertake this course. So let's move on to the actual modules where I will be explaining the steps and case studies for pipeline thickness calculation. That's all for this introduction module. Thank you. Happy learning.